Hello. I just wanted to talk you through a little experiment that I've been doing, and which has reached its conclusion, I think. And we just tell you how I started. I started looking at this circuit here, which was a Bedini self-charging circuit using 2 coils, a bridge rectifier, 3 transistors, and something with magnets on it. Well, the something with magnets on it is this. It's a CD which I've glued some magnets to. You can see it's a CD, Moby Dick. It doesn't matter which CD you use. I have some batteries, which I'll talk about in a minute. I've got the inside of an old CD player, only because it's got a nice free bearing on it. Everything else has been taken out and removed. A big coil of wire, which is something I've wound myself, and a circuit board on which the system was built, and that includes the large storage capacitor. I've attached that meter, which currently is switched off, and you probably won't be able to read anyway. Oh no, I don't know. Yeah, that currently says 0.25 volts. Okay, I didn't have a great deal of luck with the first circuit, so I've greatly simplified it, and I've now got this circuit here, which very simply uses a battery. The battery pack I talked about just now, there it is. It's just 4 Duracells with a PP3 connector on top. A switch. The switch is a magnetic switch, and I've made that out of paper clips, which is very, very difficult to see with this quality of video. But it's a paper clip which touches a piece of wire when the magnet goes round, and makes the contact. When the magnet goes away, the contact releases again. That's connected to my coil, which I showed you earlier. Okay, and the other side of the coil is connected to a bridge rectifier. You can either buy that as a bridge, or you can make it out of 4 diodes. In reality, you only need 1 diode, but if you put it in a bridge formation using 4 diodes, you get more efficient charging. And then there's the capacitor, and the little blue chap on the end here is a capacitor, and this particular one is 2200 microfarad at 63 volts. So what do we do? Well, first we'll have to put the CD on top of the CD player, like that. Okay, and it just spins nicely and freely. The reason it's stopping there is it's actually attracted to the paperclip switch, which you may be able to see moving. Try and get some more light on that. Okay, if you can see that moving as the thing goes around. Okay, and as the magnet attracts the paperclip, the contact makes the wire contact, and that energizes the coil from the battery, and that repels the magnet that's in the air gap and makes the whole thing work. So what I'm going to do now is connect the battery up. So positive to positive, negative to negative. There's my battery just touching the wires. Okay, now this thing is a little temperamental because I haven't got gold-plated contacts or anything nice like that, which is what I should ideally have, but just give it a bit of a kick. I'm just playing, adjusting the contact here with my little pen. All in the name of science, you understand? And there it goes. Okay, now it's off. As that's going round, the back EMF is being used to charge the capacitor. You can see that's now 6.7 volts, 6.8 volts, 6.9 volts, 7 volts. Now the people who think about over unity would say, oh, we're getting 7 volts out, and it's only 4 1.5 volt cells in, so therefore that must be over unity. Well, that's nonsense. The amount of power required to drive this motor is significantly greater than that we're getting out the other end. The fact we're getting 9 volts out is irrelevant. What's interesting, I think, is just the fact that it's a motor that works with a paperclip. So magnets, an old CD and a coil of wire. And there it is going around. I've got another little motor here. see that or not. If I connect that across the capacitor, if I find the right place to connect it to, the motor will in fact spin. You see that? Okay, that's the power from the Bedini motor which is causing that to spin. Okay, from the voltage that's being charged in the capacitor. And there it is working, spinning around. Perhaps if I'd done it on the other side you'd actually be able to see it better. But the paperclip is moving in and out with the magnet. The magnet's causing the magnetic field in the coil to repel the magnets and spin the motor. And the back EMF, when the contact opens, is what's charging the capacitor. And it changes with speed because the contact is not very good. But just to prove that you can build a Bedini motor, which is essentially, in this case, an interesting demonstration of generating 10.4 volts from a battery which is only 6 volts. Just to prove there's no smoke or mirrors, if I disconnect the battery, the motor stops. And you can perhaps see the paperclip. Okay, and it stops just there with the magnet attracted to the paperclip. If I reconnect the battery, the thing it doesn't like self-starting, this motor. Give it a little kick. There you go. Once you get it going, it spins up quite nicely. And that probably is where my experimentation with Bedini motors is going to finish. But good game, a lot of fun. And playing with these hugely powerful magnets is really good fun. The only thing I would say is be very careful with those magnets, the cobalt ones. If you get them within about 3 or 4 inches of each other, they do jump together. And if they jump together with great ferocity, they can actually break, as happened to one of mine. When it jumped on top of another one. Where is it? There's my broken one. You can't see it very well, it's just you can see it's slightly misshapen. The top corner's come off. That's what happened when it hit another magnet. It just jumped about 3 inches across the table, smashed into it and broke itself, which was a bit sad really. But there you go. That's my Bedini motor. 1 CD, 4 magnets, a little battery and a big coil of wire. And that's all you need to actually make the motor. Oh, and something to, some sort of bearing to sit the CD on. If you fancy building one, have fun. As I say, the circuit you actually need, the simple bit, is just the battery, the switch, which is the paperclip, which is mounted opposite the coil, directly opposite the coil, and the coil of wire, which is air cord. I don't know, about 2 inches diameter, I guess. Although the centre of the coil is probably 1 inch. There's only about maybe 3/4 of an inch of winding on the coil itself. And if you want then to get energy from this, connect also to the coil a bridge rectifier and a capacitor. Make sure the capacitor is of sufficient voltage to handle the input, otherwise it could result in a little bit of a bang and a waste of a capacitor. So I suggest you go for something like at least 25 volts, maybe 63 volts, and as many microfarads as you can get. I've got 2200. If you've got 10,000, 100,000, so much the better, because you can store that much more energy and impress your friends when you short the thing out and there's a big spark. Or run your little motor for much longer, of course. Okay, have fun guys.